What if that eerie sense of déjà vu wasn't just a trick of the mind, but a fleeting glimpse into another version of your life playing out somewhere in the cosmos? The idea of parallel universes once belonged to the realm of science fiction, but today it's a serious topic debated by physicists and philosophers alike. From the mind-bending laws of quantum mechanics to the ethical dilemmas hidden in every choice we make, the multiverse theory forces us to question everything we thought we knew about reality. In this journey, we'll uncover how cutting-edge science, blockbuster films, and age-old philosophical questions all point to one startling possibility: you might not be just one version of yourself. And the implications, they'll shake the very foundation of how you see existence, ready to have your perspective stretched beyond the limits of a single universe. Let's begin. Think of every choice you've ever made: what to eat for breakfast, whether to take that job, even which path to walk home. Now picture a reality where each of those decisions went differently. That's the heart of parallel universes, infinite alternate timelines branching out from every possible outcome. Scientists call this the many worlds interpretation, where reality constantly splits like a never-ending maze of possibilities. Quantum mechanics gives us a strange but useful analogy: Schrödinger's cat, simultaneously alive and dead inside its box until someone looks. In quantum terms, the cat isn't just in two states, it's in both, each reality existing in its own separate universe. But this isn't just a modern idea. Ancient Hindu texts describe countless overlapping worlds long before physicists put math to the concept. Whether through the lens of cutting-edge science or age-old spirituality, one thing is clear: reality might be far bigger and far weirder than we ever imagined. In 1957, a young physicist named Hugh Everett proposed a radical idea, one so daring that even some of his peers dismissed it as science fiction. He suggested that every tiny quantum event doesn't just create uncertainty, but an entirely new universe. Picture this: the moment an electron zigzags unpredictably, reality doesn't settle on one path. Instead, it splits, each possibility blooming into its own separate world. That's the many worlds interpretation, not just theory, but a cosmic tree of infinite branches growing with every choice, every chance. Take the famous double-slit experiment. When particles are fired at a barrier with two openings, they don't behave like predictable bullets. Instead, they act like waves, creating an interference pattern as if they pass through both slits at once. Observed closely, though they choose a single path, the many worlds explanation, the particle does take every possible route, just in different universes. What we see as a single outcome is only one slice of an endlessly dividing reality. But here's where things get thorny. Does this theory tidy up the messy problem of quantum measurement, or does it multiply the confusion? Supporters argue it removes the need for a mysterious observer to collapse reality into one state. Critics counter that untestable infinite universes feel more like philosophy than physics. Yet whether you find it elegant or extravagant, Everett's vision forces us to ask, if every possibility exists somewhere, what does that mean for free will, for identity, for the very nature of existence? Suddenly, the universe feels less like a clockwork mechanism and more like a kaleidoscope turning endlessly, revealing new patterns with every twist. But what if parallel universes aren't just branching timelines? What if they exist right beside us, separated by dimensions we can't even perceive? Enter string theory, where reality isn't just three-dimensional space plus time. It's an 11-dimensional symphony of vibrating strings. At the heart of this idea are brains, massive membranes floating in higher dimensions like sheets of reality stacked in a cosmic library. Some physicists, like Brian Greene, suggest these brains could each hold entire universes with their own laws of physics, some with gravity 100 times stronger, others where light moves slower than molasses. Now picture two of these brains colliding, a cosmic accident with unimaginable energy. That collision could have been our Big Bang, the violent birth of everything we know. It's a wild thought. Our universe might just be one bubble in an endless foam of brain collisions. Even stranger, the holographic principle, which hints that all the information in our three-dimensional universe might actually be encoded on a two-dimensional surface at its edge, like a movie projected from the walls of reality itself. So are we living in a hologram sandwiched between unseen dimensions? The math suggests it's possible, but here's the catch. We're like flatland creatures trying to imagine a cube. Our brains evolved for survival, not for picturing curled-up dimensions or shadow universes drifting millimeters away in directions we can't point to. Yet with every breakthrough in theoretical physics, the multiverse keeps inching from metaphor to mathematical possibility, one vibrating string at a time. Picture a pot of water on the stove, the surface simmering, bubbles forming and expanding, each one a self-contained pocket of steam. Now imagine that on a cosmic scale, where space itself is the boiling medium, and each bubble isn't just a fleeting pocket of air, but an entire universe with its own rules of physics. That's the essence of cosmic inflation theory, proposed by physicist Alan Guth in the 1980s. His idea wasn't just about explaining the Big Bang, it suggested that our universe might be one accidental bubble in an endless, frothing sea of realities. Here's how it works. In the earliest moments after the Big Bang, space didn't just expand, it ballooned exponentially faster than the speed of light, stretching the fabric of reality like taffy. But inflation didn't stop everywhere at once. Some regions kept stretching while others snapped into stable universes like ours. The result, a multiverse of bubble realities, each with its own distinct physics. Some with stronger gravity, others where atoms never even formed. And here's the kicker: dark energy, that mysterious force accelerating our universe's expansion, might just be leftover energy from inflation's sudden halt. In other bubble universes, that energy could have settled differently or not at all. Some might collapse instantly, while others stretch into cold, empty voids. So are we just lucky to live in a bubble where physics allows galaxies, planets, and life? Or is this another clue that reality is far grander and far stranger than we ever suspected? The math suggests inflation never truly ends, meaning new bubbles are constantly budding into existence, each a fresh experiment in the laws of physics. It's a humbling thought. Our entire cosmos might just be one accidental universe in an infinite cosmic foam. What if the universe's deepest mystery isn't hidden in distant galaxies, but in the very code of reality itself? The simulation hypothesis flips everything we think we know on its head, suggesting our world might not be the base layer of existence, but an artificial construct, an advanced civilization's version of a historical video game. Philosopher Nick Bostrom laid out a chillingly logical case for this idea back in 2003. He argued that if any civilization ever reaches the technological height to simulate conscious beings, they'd likely create countless simulations, meaning the odds of us living in the original, real universe could be statistically zero. Elon Musk famously put it this way: the chance we're not in a simulation is 1 in billions. Think about how rapidly gaming graphics have evolved from blocky pixels to near photorealistic virtual worlds. Now project that forward 1,000 years. If humans, or some distant descendants, perfect simulations indistinguishable from reality, what's stopping them from running trillions of them? Suddenly, our daily lives, the smell of rain, the warmth of sunlight could just be exceptionally convincing lines of code. But here's where philosophy crashes into physics. If we're simulated, does that make our emotions less real? Or does it redefine what real even means? Ancient thinkers like Plato pondered this with his allegory of the cave, questioning whether we're mistaking shadows for substance. Modern skeptics counter that if reality is software, where's the evidence of glitches or rendering limits? Yet some theorists point to quantum indeterminacy, the way particles behave only when observed as potential, processing shortcuts in a cosmic simulation. Whether you find the idea exhilarating or unsettling, it forces a radical shift in perspective. If consciousness can be coded, does that diminish our humanity, or reveal that existence might be far more malleable than we ever dreamed? The simulation hypothesis doesn't just ask if we're NPCs in some grand design. It asks us to question the very nature of the stage we're standing on, and who or what might be watching from beyond the screen. Imagine stepping into a room with a loaded gun pointed at your head, one that has exactly a 50% chance of firing when you pull the trigger. Now, according to the many worlds interpretation, pulling that trigger doesn't just create one reality where the gun fires and another where it doesn't. Instead, your consciousness splits. You experience both outcomes simultaneously, but only continue perceiving the reality where you survive. This unsettling thought experiment, called quantum suicide, suggests something even more startling. From your perspective, you might literally be immortal. Physicist Max Tegmark took this idea further, proposing that consciousness itself could act like a branching river, flowing only along the paths where sentient observers continue to exist. In essence, every time a life-threatening event occurs, your awareness would always find itself in the timeline where you live, no matter how improbable the odds. It's a paradox wrapped in existential vertigo. Are we just the lucky versions of ourselves that never experience death, or is there something deeper at play? Critics argue this veers dangerously close to solipsism, the notion that only one's own mind is sure to exist. After all, if consciousness is perpetually shunted into favorable realities, what happens to the versions of you that don't make it? Are they simply erased like corrupted files, or do their experiences still matter somewhere in the multiverse? Supporters counter that this isn't magic, it's math. If every quantum possibility manifests somewhere, then statistically, there's always a universe where the unthinkable doesn't happen. Yet the implications ripple far beyond thought experiments. If consciousness truly is a filter that only perceives survivable outcomes, does that reshape how we understand risk, mortality, or even the nature of reality itself? It's a dizzying proposition that death for the observer might not be an endpoint, just a path their awareness never travels. Whether science or speculative philosophy, one thing is certain: the multiverse keeps rewriting the rules of existence in ways that challenge everything we think we know. Changing even the smallest detail in history might not just rewrite our timeline, it could tear open an entirely new reality. Take the chilling thought experiment of traveling back to kill someone like Hitler. Would that truly prevent World War II, or would it simply fracture the timeline, birthing a universe where history plays out differently while our original past remains untouched? This is the heart of the butterfly effect on a cosmic scale, where every tweak to history could ripple outward into infinite alternate branches. Blockbuster films give us two starkly different visions of how this might work. In Back to the Future, Marty McFly's actions start erasing his own family from existence, the photo slowly fading as his future unravels. But the Avengers take a different approach. When they mess with time, they don't rewrite their own past. Instead, they create entirely new, branched realities, like stepping on a cosmic twig that snaps off to grow its own parallel universe. Which version is more scientifically plausible? Enter the Novikov self-consistency principle, a mind-bending idea from Russian physicist Igor Novikov. He argued that any actions taken by time travelers must logically already be part of history, meaning you couldn't actually change the past, only fulfill what always happened. Think of it like a cosmic rubber band. The universe would always snap back to prevent paradoxes. Try to shoot your grandfather before he meets your grandmother. The gun would jam, or your aim would fail because your own existence proves the attempt never succeeded. Yet quantum mechanics throws a wrench into this tidy idea. If every quantum decision spawns new universes, why couldn't time travel do the same? Perhaps the moment you arrive in the past, reality forks, one branch where history plays out unchanged and another where your actions birth a fresh timeline. Suddenly, the debate isn't just about changing history, but about whether time itself is a single, unbreakable thread or an endlessly splitting rope. Here's the real kicker: if alternate timelines can form from every tiny choice, what does that say about the weight of our daily decisions? Maybe that argument you had yesterday spun off a universe where you chose kindness instead. Maybe somewhere in the vast cosmic tapestry, every road not taken is still being traveled by other versions of you. Statistically speaking, there's a version of you out there, maybe countless versions, living lives so similar yet so different that they might as well be cosmic reflections. The numbers are staggering. In an infinite multiverse, your quantum doppelganger could exist roughly 10 to the power of 10 to the 29 meters away. That's a 1 followed by more zeros than there are atoms in the observable universe. So what does that alternate you look like? Maybe they took that job offer abroad while you stayed home, or chose a different partner, tiny forks in the road that led to entirely different destinations. Now here's where physics gets eerie. Quantum entanglement, what Einstein famously called spooky action at a distance, suggests that particles can become linked across vast stretches of space, instantly influencing each other no matter how far apart they are. If two electrons are entangled, changing the spin of one automatically flips the other, even if they're on opposite sides of the galaxy. Could something similar connect you to your parallel selves? Some theorists speculate that if the multiverse is real, these entangled states might stretch between universes, creating unseen threads tying realities together. Imagine a cosmic switchboard where choices in one world ripple into another. But don't pack your bags for a doppelganger meetup just yet. Even if alternate versions of you exist, the sheer scale of the multiverse likely makes crossing over impossible. Those other versions aren't just in another galaxy. They're in another reality, separated by dimensions we can't access. Yet the thought lingers, somewhere in some other slice of existence, another you is sipping coffee, staring at a screen, wondering the same thing. And if entanglement truly bridges worlds, could those versions ever, in some intangible way, sense each other? Science says no, but the poetry of the idea. That's harder to dismiss. After all, in a multiverse where every possibility plays out, who's to say what's truly impossible? Have you ever been absolutely certain about a childhood memory, only to discover the world insists it never happened that way? This unsettling phenomenon has a name: the Mandela effect, named after Nelson Mandela because thousands vividly recalled his death in prison during the 1980s despite him actually passing away in 2013. It's as if collective memories slipped between realities, leaving behind eerie discrepancies. Take the Berenstain Bears. Many swear the beloved book series was spelled Berenstein with an E, not the official A. Or consider the non-existent 90s movie Shazam, starring Sinbad as a genie, a film that never existed, yet countless people describe its plot, posters, even rental store VHS tapes. These aren't just misremembered details. For those affected, the certainty feels bone deep, like reality itself has been subtly rewritten. Psychologists offer a straightforward explanation: false memories. Our brains are storytelling machines, filling gaps with plausible fabrications. When groups share similar cultural references, like mishearing song lyrics, these errors spread like mental wildfires. But could there be more to it? Some theorists suggest these glitches are evidence of universe hopping, where fragments of alternate timelines bleed into our own. Imagine cosmic waves crashing between parallel realities, leaving behind mental debris like déjà vu with receipts. Enter CERN Large Hadron Collider. This massive particle accelerator manipulates forces that could, hypothetically, ripple through spacetime. While mainstream science dismisses any connection to the Mandela effect, the timing of certain memory shifts, like people reporting the Monopoly man suddenly lacking a monocle, coincides with high-energy experiments. Coincidence almost certainly, yet in a multiverse where every possibility exists, even the wildest what-if can't be entirely ruled out. So are we all victims of faulty neurons or unwitting travelers in a quantum labyrinth? The truth might be stranger than either option. After all, memory is the only record we have of reality, and if that record can't be trusted, what does that say about the world we think we know? Whether glitch or trick of the mind, the Mandela effect forces us to confront a humbling idea. Reality might be far less solid than it seems. Pop culture has turned the multiverse from a fringe physics theory into a playground of infinite storytelling. But how much scientific truth hides beneath the wild adventures? Take Rick and Morty's central finite curve, that cosmic border wall separating universes where Rick is the smartest being from all other realities. At first glance, it sounds like pure sci-fi whimsy until you dig deeper. The show's writers tapped into a real scientific debate. Could the multiverse have neighborhoods where certain rules or traits cluster? Some physicists speculate that universes with similar fundamental constants might group together like bubbles in foam, making Rick's egotistical enclave less absurd than it seems. Then there's Everything Everywhere All at Once, where characters tap into alternate lives by embracing absurdity, like hot dog fingers or rocks with subtitles. While the film takes creative liberties, its core idea mirrors quantum mechanics, many minds interpretation. Every possible version of you exists somewhere, and consciousness might just be the thread stitching them together. The movie's emotional punch, that even in infinite chaos, love anchors us, resonates with physicists who see the multiverse not as cold equations, but as a tapestry of interconnected stories. Marvel took a darker turn with Loki's sacred timeline, where a bureaucratic agency prunes wrong realities to prevent a multiversal war. It's a chilling metaphor for the tension between order and chaos, but does it hold up to science? The concept echoes something called eternal inflation, where some universes stabilize like the sacred timeline while others keep expanding uncontrollably. Yet critics argue Marvel got one thing backward. In reality, branching timelines can't be erased. They just continue unseen, like parallel trains racing down separate tracks. What makes these stories compelling isn't just their flashy special effects, it's how they grapple with the same existential questions physicists wrestle with. If every choice spawns a new universe, do our actions lose meaning? Or does the multiverse make them matter more because every possibility gets its chance to exist? Pop culture doesn't just entertain us with these ideas, it primes us to think critically about the nature of reality itself. After all, the line between science and fiction has always been thinner than we think. There's a man who's cheated death not once, not twice, but 7 times, each incident more statistically improbable than the last. A fall from a 5-story building, a drowning in frozen waters, even a head-on collision with a truck. Yet here he is, alive to tell the tale. Stories like his aren't just freak accidents, they're the kind of unexplained phenomena that make physicists pause. Could these survivors be living proof of quantum immortality? The idea that consciousness somehow locks onto timelines where survival is possible, no matter how slim the odds. Take the case of a woman who walked away from a plane crash that should have been unsurvivable. The wreckage was a smoldering heap, yet she emerged with barely a scratch. Investigators called it a miracle, but quantum theory offers another explanation. In an infinite multiverse, there's always a version of events where the improbable happens. For every observer, their consciousness only experiences the timelines where they persist, like a cosmic game of Russian roulette where you never hear the fatal click. But here's where things get thorny. If quantum immortality is real, why do we still witness tragedy around us? Why don't all near-death experiences end in miraculous survival? Critics argue these cases are just statistical flukes, the inevitable outliers in a world governed by probability. After all, with billions of people on Earth, someone has to be that 1 in a billion survivor. Yet supporters counter that the math of the multiverse doesn't care about human intuition. If every possible outcome exists somewhere, then from a survivor's perspective, their continued existence isn't luck, it's inevitability. Perhaps the most unsettling question isn't whether these stories prove quantum immortality, but what they imply about the nature of death itself. If consciousness truly branches with each life or death moment, does that mean the end of one thread is just a pause in another? Science doesn't have definitive answers yet, but one thing's certain: in a universe where reality might be endlessly dividing, even the impossible deserves a second look. Picture a world where the Roman Empire never crumbled, where its roads still stretch across continents, its senators debate in marble halls, and Latin remains the lingua franca of global trade. Historians call this the Pax Romana forever scenario, but in the multiverse, it might not be hypothetical. If every possible outcome spawns a new reality, there's a timeline where Rome's legions repelled the barbarians, where Constantinople never fell, and where the Renaissance unfolded under the shadow of an unbroken imperial eagle. Now shift gears entirely. Imagine dinosaurs never vanishing after that fateful asteroid strike. In that alternate Cretaceous, mammals might have remained tiny nocturnal creatures, never evolving into the dominant life forms that eventually birthed humanity. Picture Triceratops herds grazing where skyscrapers stand today, or a highly evolved descendant of velociraptors discovering fire instead of us. Paleontologists call this the Dinosauria continuum, and while it sounds like a B-movie plot, the math of cosmic inflation suggests such worlds could exist just in a bubble universe where that 6-mile-wide space rock missed Earth by a few critical minutes. But here's where counterfactual history collides with cutting-edge physics. The Battle of Thermopylae, Genghis Khan's conquests, even the Industrial Revolution, each pivotal moment represents a quantum fork in the road. Had Napoleon's cavalry arrived 30 minutes earlier at Waterloo, or if the Library of Alexandria's scrolls survived the flames, entire civilizations might have charted radically different courses. In our world, these events settled into fixed history, but the multiverse says every what-if became someone's reality somewhere. Take the Cold War's razor's edge moments. In one universe, the Cuban Missile Crisis spiraled into nuclear winter. In another, diplomacy prevailed so thoroughly that the Berlin Wall never rose. Neither timeline is more real than ours, just different branches on the cosmic tree. This isn't mere speculation, it's a logical extension of Everett's equations. If quantum events spawn universes, why not human decisions? The terrifying, liberating truth is this: history isn't a single story. It's every story playing out simultaneously across the multiverse's infinite stages. So the next time you wonder how different the world could have been, remember, it is different. Somewhere the dinosaurs still rule, Rome never dimmed its glory. And alternate versions of you are living all those unmade choices in realities where history took the roads we didn't. The static crackles on the old recording, just empty noise at first. Then, faint but unmistakable, a voice whispers back an answer no living person spoke. These electronic voice phenomena, or EVP recordings, have long been dismissed as pareidolia, our brains tricking us into hearing patterns where none exist. But what if those ghostly voices aren't hallucinations or hoaxes? What if they're leakage from parallel dimensions bleeding into our own? Consider how radio works, tuning a dial to catch signals floating invisibly around us. Now imagine consciousness operates similarly, with certain minds or devices accidentally picking up whispers from realities stacked infinitesimally close to ours. Mediums who claim to channel spirits might unknowingly be tapping into alternate versions of the deceased echoes of lives that played out differently elsewhere in the multiverse. Even Ouija boards take on an eerie new plausibility. Those planchette movements could be quantum vibrations from timelines where the other side isn't an afterlife but a neighboring universe. Skeptics rightly point out the lack of concrete evidence, yet physics offers intriguing parallels. Quantum tunneling shows particles occasionally teleporting through barriers they shouldn't bypass, a phenomenon that, scaled up, might allow information to slip between dimensions. String theory's hidden dimensions could serve as cosmic hallways connecting realities. And if entanglement links particles across space, why not across branes of existence? The most unsettling implication, those EVP voices insisting their loved ones might not be lying. In a branching multiverse, every relationship has infinite variations, some where bonds were never broken, others where connections formed differently. A mother's voice from beyond might genuinely be a version of her, just not yours. This reframes centuries of paranormal accounts not as supernatural hauntings, but as accidental interdimensional crosstalk. Of course, extraordinary claims demand extraordinary proof, but in a reality where parallel worlds might be inevitable, dismissing these mysteries outright could be just as unscientific as blindly believing. Perhaps the truth lies somewhere in the static between the frequencies of what we know and the infinite possibilities we're only beginning to imagine. Some of the most profound evidence for parallel universes isn't found in particle colliders or cosmic radiation. It's hidden in plain sight, scribbled in the margins of old notebooks. Mathematics has always been the silent architect of reality, from the swing of a pendulum to the orbit of planets. But what if math isn't just a tool we use to describe the universe? What if it is the universe? That's the radical claim of physicist Max Tegmark's mathematical universe hypothesis. He proposes a staggering idea. Every possible mathematical structure isn't just an abstract concept, it physically exists as its own separate reality. Take imaginary numbers, those seemingly nonsensical equations with the square root of -1. For centuries, mathematicians dismissed them as useful tricks with no basis in the tangible world. Yet today, they're the backbone of quantum mechanics, describing particles that exist in multiple states at once. Could these imaginary quantities actually be footprints from alternate dimensions, shadowy hints of structures lying just outside our perceptual reach? Tegmark argues that if a universe can be described mathematically, then somewhere it must exist, not as a simulation, not as a metaphor, but as a concrete parallel reality. This isn't just philosophical musing. String theory relies on 10 or 11 dimensions to make its equations work. Calabi-Yau manifolds' complex, 6-dimensional shapes dictate how strings vibrate to produce different particles. We can't see these extra dimensions, but the math insists they're there. Tegmark takes it further. If a universe can exist with 4 dimensions or 11, why not one where geometry operates entirely differently? A reality where circles have sharp edges or where time loops like a Möbius strip. Critics counter that confusing mathematical elegance with physical existence is a category error, like mistaking a blueprint for a building. But supporters point to the uncanny effectiveness of math in explaining the cosmos, from black holes to DNA. Why does nature obey mathematical laws at all unless math is woven into its very fabric? The answer might rewrite not just our understanding of parallel worlds, but the nature of existence itself. If Tegmark is right, the multiverse isn't a speculative maybe, it's a mathematical certainty, written in numbers we're only beginning to decode. What if consciousness isn't anchored to a single reality, but flickers between them like a cosmic radio scanning stations? This isn't sci-fi fantasy. It's the heart of the Orch or theory, proposed by physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff. They suggest that deep inside your brain's neurons, tiny structures called microtubules might be running quantum computations processes so delicate they could bridge parallel worlds. Picture these microtubules as microscopic antennas, tuning into different frequencies of existence. every thought, every decision might not just alter your brain's chemistry, it could nudge your awareness toward alternate versions of reality. Now consider near-death experiences. Those who have teetered on the edge often describe eerily similar visions, tunnels of light floating outside their bodies, even encounters with otherworldly beings. Mainstream science chalks this up to oxygen deprivation or firing neurons, but Orch offers another explanation. What if these moments are glimpses of consciousness momentarily unmoored from its home reality, skimming across nearby universes before snapping back? Then there's DMT, the so-called spirit molecule. When people ingest this powerful psychedelic, they report visiting impossible realms, geometric landscapes, entities made of light, a sense of cosmic connection. Strangely, these visions overlap across cultures, as if users are tapping into some shared layer of existence. Could DMT temporarily dissolve the quantum boundaries in microtubules, letting consciousness wander the multiverse like a tourist without a map? Critics argue these are just hallucinations, neural noise masquerading as meaning. Yet the consistency of these experiences raises haunting questions. If every brain hallucinates the same way, is it still a hallucination or a window? The implications are dizzying. If consciousness truly hops between realities, then death might not be an end, just a permanent shift to another branch of existence. Free will takes on new weight. Every choice could literally steer you toward a different universe, and those uncanny moments of déjà vu, maybe they're flashes of overlap, echoes from paths almost taken. Orch remains controversial, but it forces us to ask, are we passive observers of reality, or active participants shaping it with every flicker of thought? The answer might lie deeper than neurons buried in the quantum fabric of existence itself. Picture the universe as a spiderweb stretched across dimensions. What we see isn't the whole structure, just the threads glinting in our limited light. Dark matter, that mysterious substance making up 85% of the cosmos, has eluded detection for decades. But what if it's not hiding in our universe at all? Lisa Randall, a Harvard physicist, flipped the script with a daring idea. Dark matter might be gravity itself, seeping into our world from a parallel brain just millimeters away in higher dimensional space. Think of it like this: two sheets of paper lying flat on a table, never touching. If ants lived on one sheet, they'd have no idea the other existed until a marble rolled between them. The indentation would warp both pages, creating a force the ants couldn't see or explain. That's Randall's warped dimension theory in action, the gravity we attribute to invisible dark matter. It could actually be the tug of entire galaxies in a neighboring brain, their mass distorting the fabric of our reality like cosmic shadows. At CERN, scientists are testing this by hunting for gravitons, hypothetical particles that might carry gravity between dimensions. If they exist, they'd be messengers from a parallel universe, proof that dark matter isn't missing, just misassigned. The math checks out. Randall's models show how a warped fifth dimension could amplify gravity's weakness in our universe while keeping other forces localized. It's like living on one side of a mountain. You'd never feel the wind battering the other slope, but its weight still shapes the land beneath you. Skeptics argue this is a clever workaround for dark matter's elusive nature. Yet the alternatives, like sterile neutrinos or primordial black holes, have their own gaps. Randall's brilliance lies in reframing the question. Instead of asking what dark matter is, she asks where. And in a multiverse where dimensions rub shoulders, the answer might rewrite not just cosmology, but our very place in the cosmic order. So next time you gaze at the night sky, consider this: the force holding galaxies together might not belong to our universe at all. It could be the fingerprint of another reality, pressing gently against ours from just beyond the veil of perception, a silent partner in the dance of the cosmos. Imagine a computer so powerful it doesn't just calculate possibilities, it lives them, simulating entire alternate timelines like parallel threads in a cosmic tapestry. That's the promise of quantum computing in multiverse research, where machines like Google's Sycamore processor aren't just solving problems, they're peeking into realities that might otherwise stay hidden. Take time crystals, a bizarre quantum phase of matter where atoms pulse in repeating patterns without energy input, defying the usual laws of thermodynamics. Google's team created these in 2021, effectively building a system that ticks like a clock with no gears. Why does this matter for the multiverse? Time crystals could act as quantum simulators, modeling how alternate versions of reality might evolve, like running a cosmic experiment in ultra-fast forward. Then there's D-Wave's quantum annealing, a method that doesn't just brute force calculations but explores solutions like a hiker navigating a fractal landscape. When researchers used it to map protein folding, they glimpsed something profound. The algorithm didn't settle on a single optimal shape. Instead, it surfaced multiple stable configurations, echoing the many worlds idea that every quantum decision spawns new branches. Critics argue these experiments are still baby steps, far from simulating full-fledged universes, yet the implications are staggering. If quantum computers can model alternate timelines, could we one day test theories like Everett's branching realities, not with abstract math but with observable data? It's a slippery slope, proving the multiverse might require technology so advanced it becomes indistinguishable from the phenomenon it's studying. Here's where philosophy collides with silicon. If a quantum simulation generates conscious beings, even digital ones, do they have their own parallel existences in the simulation's framework? Suddenly, mapping the multiverse isn't just about physics. It's about ethics, identity, and whether we're playing with cosmic fire by creating realities inside machines. Whether time crystals and annealing are the keys to other worlds, or just fascinating curiosities, one thing's certain: the line between simulating universes and creating them is getting blurrier by the day. Ancient Buddhist texts describe vast, layered realms of existence, from the fiery depths of the Narakas to the luminous heavens of the Devas, each inhabited by beings shaped by their karma. Strikingly, this vision of multiple coexisting realities mirrors modern multiverse theories in ways that defy coincidence. Where science speaks of quantum branches and bubble universes, Buddhist cosmology describes 31 planes of existence, all interwoven yet invisible to one another. Could these ancient teachings have grasped something fundamental about reality's structure, glimpsed through meditation rather than mathematics? The Dalai Lama himself has remarked that if science ever disproved reincarnation, Buddhism would have to adapt. But when it comes to parallel worlds, the opposite seems true. The more physics uncovers, the more it echoes spiritual concepts. Take quantum superposition, where particles exist in multiple states until observed. In Buddhist philosophy, reality is similarly fluid, with perception shaping experience. The difference lies in framing. Physicists call it wave function collapse. Monks might call it the illusion of a fixed self encountering Maya, the veil of appearances. Yet what happens when we bring divine creation into the equation? The Vatican's own astronomers have surprisingly embraced the multiverse concept. Father Gabriel Funes, former director of the Vatican Observatory, stated that a limitless cosmos doesn't contradict faith, it magnifies God's creativity. Jesuit brother Guy Consolmagno, a planetary scientist, goes further. If alternate universes exist, he jokes, God's probably been saving the best one for us. This openness reveals a fascinating middle ground where science and spirituality aren't at war but in dialogue, each offering its own lens on the infinite. Still, tensions linger. Some theologians argue that positing infinite worlds diminishes humanity's special place in creation. Others counter that a multiverse doesn't erase divinity, it expands the canvas on which a creator might work. Meanwhile, Buddhist teachers like Thich Nhat Hanh reframe the debate entirely. Reality is a manifestation of mind, he wrote, suggesting that both quantum worlds and spiritual realms emerge from consciousness itself. Perhaps the truth lies beyond either slash or. Whether through prayer or particle accelerators, humans have always sensed that reality runs deeper than the eye can see. The multiverse doesn't have to erase the sacred. It might just reveal how much grander the mystery really is. After all, if the cosmos can birth infinite versions of itself, who's to say it can't also hold space for something even science can't measure? Nature has a funny way of repeating itself, like two artists independently painting the same scene. Take the marsupial wolf of Australia and its near-identical placental cousin from other continents. They shared the same sleek build, sharp teeth, even hunting behaviors, yet evolved oceans apart, separated by millions of years. Scientists call this eerie similarity convergent evolution, where unrelated species sculpt themselves into mirror images. But what if there's another explanation? Could these doppelgangers be echoes of timeline cross-contamination, whispers from branches where land bridges never sank or continents drifted differently? Now consider cryptids, those elusive creatures like Bigfoot or the chupacabra that slip through eyewitness accounts but evade capture. Skeptics dismiss them as hoaxes or misidentified animals. Yet in a multiverse where realities brush against each other, might some cryptids be refugees from neighboring dimensions? Imagine a universe where Ice Age megafauna never went extinct, or where human expansion didn't erase wilderness corridors. A stray quantum fluctuation could nudge a creature through the cosmic seams, leaving bewildered hikers to glimpse what shouldn't exist here. The evidence is tantalizingly circumstantial. Reports often cluster around geological rifts or areas with intense electromagnetic activity, conditions some theories suggest might thin the barriers between worlds. Even indigenous legends speak of shape-shifting beings or spirit animals that move between realms, as if ancient cultures intuited the multiverse long before physicists named it. Of course, mainstream biology offers simpler answers. Parallel adaptations arise because certain body plans just work for specific niches. But in a reality where every possibility plays out somewhere, the line between textbook science and fringe speculation blurs. Whether cryptids are dimensional tourists or just undiscovered fauna, one thing's certain: Earth's evolutionary story might be far stranger and more interconnected than we ever guessed. What if your most vivid dreams weren't just random brain static but secret doorways into parallel versions of your life? Lucid dreaming, that electrifying moment when you realize you're asleep and seize control, might be more than a neurological quirk. For Tibetan monks practicing dream yoga, it's a centuries-old spiritual technology, a way to consciously navigate alternate realms of existence. They train for years to maintain awareness in the dream state, treating it as real as waking life. Meanwhile, MIT's Dream Engineering Lab is taking a radically modern approach, using targeted sound cues and wearable tech to induce and guide lucid dreams on demand. Both traditions, ancient and cutting-edge, point to the same tantalizing possibility, that dreams could be our brains' built-in multiverse simulator. Picture this: you're floating above your sleeping body, then suddenly you're in a classroom from childhood, except the walls are breathing and your third-grade teacher has wings. Neuroscientists explain this as your thalamus, the brain's reality filter, taking a nap while memory and emotion run wild. But Tibetan texts describe these experiences as bardo states, liminal zones between incarnations where consciousness can explore other planes of existence. The parallels are eerie. Both frameworks suggest dreams aren't mere fiction but alternate modes of perception. At MIT, researchers are hacking into this process with techniques like targeted memory reactivation. Participants wear gloves that play soft tones when they enter REM sleep, a sonic nudge that whispers, "Hey, you're dreaming now." Early results show subjects gaining dream control faster, some even reporting encounters with other selves who seem aware their dream projections. One participant described meeting a version of herself who calmly explained, "I'm you, but from where it didn't rain yesterday." Spooky, absolutely, but in a many worlds framework, it raises a chilling question. Could lucid dreaming be less about creating fantasy and more about tuning into realities that already exist? The Tibetan practice takes it further. Advanced dream yogas describe shared dream spaces experienced simultaneously by multiple practitioners, and even dream artifacts that persist across nights. One monk's account tells of finding a cryptic book in a dream, studying it for weeks within the dreamscape, only to later encounter its real-world counterpart in a remote monastery library. Coincidence, perhaps, yet if consciousness can entangle particles across space, why not across the gossamer walls of alternate realities? Whether through meditation or tech, the message is the same. Your nighttime adventures might be more than synaptic sparks. They could be glimpses through the cosmic keyhole, proof that the line between dream and reality is far thinner than we ever dared imagine. So tonight, when you close your eyes, ask yourself, are you just drifting off to sleep or stepping onto the multiverse's grandest stage? That uncanny sensation, walking into a room you've never entered before, yet feeling every detail is hauntingly familiar, might be more than just a brain glitch. Neuroscience typically explains déjà vu as a brief misfire where memories form and recall almost simultaneously, creating an illusion of repetition. But quantum theories suggest something far stranger. What if these fleeting moments are actual glimpses into alternate timelines where you have been here before? Researchers at MIT have induced eerily similar experiences using targeted electromagnetic pulses to the brain's temporal lobe, essentially triggering false memories on demand. Participants suddenly swore they recognized unfamiliar faces or places, describing sensations indistinguishable from spontaneous déjà vu. This raises a provocative question. Could natural electromagnetic fluctuations like those from solar storms or even Earth's own magnetic field momentarily thin the barriers between parallel realities, letting echoes of other timelines bleed through? The overlap theory gains traction when you consider how quantum particles entangle across space. If two electrons can instantaneously mirror each other's states despite being light years apart, why couldn't consciousness rooted in those very particles also experience fleeting synchronizations with its counterparts in other branches of reality? Tibetan Buddhists have a term for this, pei wal, or between moments, when the fabric of perceived reality grows thin. Skeptics argue these ideas venture into untestable speculation. Yet the inverse is equally fascinating. If déjà vu is purely neurological, why does it so often accompany profound emotional weight, as if brushing against a life you almost lived? Whether a quirk of biology or a crack in the multiverse, one thing's clear: that spine-tingling sense of sudden familiarity remains one of consciousness's most tantalizing mysteries. Next time it happens, pause. That whisper of recognition might not be your memory playing tricks. It could be another version of you reaching across the branches of time. At the heart of every black hole lies a singularity, a point where gravity becomes infinite and all known laws of physics break down. But what if that terrifying void isn't an end at all? Renowned physicist Kip Thorne proposed a radical twist. These cosmic monsters might actually be backdoor passages to other realities. The math is mind-bending yet shockingly elegant. According to Einstein's equations, a spinning black hole's singularity could stretch into a tunnel, a wormhole connecting distant points in space or even entirely different universes. Interstellar brought this concept to life with its breathtaking portrayal of Gargantua, a black hole so meticulously designed that Thorne co-authored a scientific paper just to explain its physics. Remember the scene where Cooper plunges into the abyss, only to find himself floating in a kaleidoscopic tunnel of light? That wasn't pure Hollywood fantasy. Thorne's calculations show that a sufficiently advanced civilization might stabilize a wormhole with exotic matter, hypothetical stuff with negative energy that could prop open the throat of the tunnel like cosmic scaffolding. Yet here's the catch, traversing one remains a lethal gamble. The tidal forces near a black hole's event horizon would stretch you like taffy in a process physicists call spaghettification. Even if you survived, Hawking radiation near the singularity might fry you to a crisp. But what if some black holes are gentler? Thorne's models suggest that wormholes with just the right spin and charge could, in theory, be navigated without turning travelers into quantum confetti. The trick lies in balancing forces so precisely that the tunnel stays open longer than a Planck second, offering a fleeting window for passage. Critics argue that without proof of exotic matter, wormholes remain speculative. But recent observations of black hole mergers hint at anomalies, echoes in gravitational waves that some speculate could be evidence of something beyond. Whether these cosmic shortcuts exist or not, the mere possibility reshapes how we see the universe. A black hole might not be a one-way trip to oblivion. It could be a revolving door with other realities just on the other side. Imagine uncovering the history of the cosmos not by digging through layers of rock, but by decoding faint ripples in space itself, like reading the universe's diary written in light. The cosmic microwave background, that faint glow from the Big Bang's afterglow, might hold more than just snapshots of our universe's infancy. Some physicists suggest it could carry whispers of other universes, echoes from timelines that branched off long ago, leaving subtle scars in the fabric of reality. This isn't just stargazing, it's quantum archaeology where the ultimate excavation tool is mathematics. Think of the CMB as a cosmic fingerprint, its temperature fluctuations mapping the universe's primordial bumps and wrinkles. But what if some of those patterns don't fit our universe's story? In 2018, researchers at the University of Durham spotted unusual, cold spots, regions where the CMB's temperature dips inexplicably. One radical explanation: these could be collision scars from bubble universes brushing against ours in the multiverse's foam. Like archaeologists piecing together shattered pottery, scientists are developing algorithms to sift through the noise, hunting for statistical anomalies that might reveal the contours of lost realities. The real mind bender comes when we ask, could we reconstruct an extinct universe from these imprints? Harvard physicist Lisa Randall compares it to forensics. If a bullet passes through two walls, the exit wound in the second wall hints at the bullet's path through the first. Similarly, if a neighboring universe grazed ours, the distortion in the CMB might let us reverse engineer its properties. Energy levels, expansion rates, even the physics that governed it, all theoretically decipherable from the bruises left behind. Yet the challenges are staggering. Distinguishing a multiverse's fingerprint from random cosmic noise is like trying to hear a single violin in a hurricane. Some argue it's a fool's errand without direct observation. These resurrected universes remain mathematical ghosts. Others counter that absence of evidence isn't evidence of absence. After all, we once thought detecting gravitational waves was impossible until we built LIGO. Whether these cosmic echoes are multiversal graffiti or just statistical flukes, the pursuit itself reshapes our understanding of reality. If the past isn't just our past, but a mosaic of forsaken timelines, then history, cosmic or human, isn't a single thread. It's a tapestry woven from every path taken and every road untraveled, with the CMB as its most cryptic stitch. Here's the next part of the script. Every choice you've ever agonized over, every sleepless night replaying what you should have done, might not just be a moment of personal reflection. In a multiverse where every possible decision plays out somewhere, regret takes on a strange new meaning. If there's a version of you that did take that job, did say yes to that relationship, did walk away when it mattered, does wrestling with guilt or remorse in this timeline even matter? Philosophers call this the moral diffusion problem. When consequences splinter across infinite realities, personal accountability starts to feel slippery. Think of it like a cosmic democracy. Every choice you could have made gets its own universe, so no path is truly abandoned. just outsourced. Some argue this erodes ethics entirely. Why agonize over right and wrong if every outcome exists regardless? But here's the counterintuitive twist. The multiverse might make morality more urgent, not less. Consider Schrödinger's cat, again alive in one world, dead in another. Does knowing the cat survives somewhere make its death in this box any less tragic? Of course not. Pain and consequence don't vanish just because alternate versions of events exist. The same applies to human actions. Hurting someone in this reality isn't softened by the fact that another you chose kindness. Regret, then, might not be futile. It could be the compass that grounds us. Neuroscientists find that dwelling on past mistakes activates learning circuits, effectively training the brain to do better next time. In a branching multiverse, that next time isn't hypothetical. Somewhere, your future selves will face similar crossroads. The weight of your choices here could ripple across realities, not by altering them, but by shaping which versions of you grow wiser. Critics push back. If every misstep spawns a universe where things went right, why strive for goodness at all? The answer lies in the stories we tell ourselves. Whether in one world or many, this version of you, the one reading these words, only experiences one lifeline. The branches may be infinite, but the path you're on, it's yours alone. So the next time you lie awake wondering, what if, remember, the multiverse doesn't erase responsibility. It just reminds us that every moment is a fork in the road, and the version of reality you're steering is still worth navigating with care. Picture stepping into a sleek silver pod, strapping in as the hum of a quantum stabilizer fills the air. This isn't space travel, but something far stranger. The screen flickers to life, displaying a menu of realities. A timeline where dinosaurs never went extinct. A world where your childhood crush said yes. Even a dimension where chocolate is a health food. Welcome to the frontier of parallel universe tourism, where the ultimate vacation isn't about where you go, but which version of reality you visit. The technology, at least in theory, borrows from wormhole physics and quantum tunneling. A carefully calibrated energy field could hypothetically pry open microscopic gaps between brains, creating temporary bridges to adjacent timelines. Think of it like cosmic skin diving. You'd only have minutes to glimpse another world before snapping back to your home reality. Early prototypes would be strictly observational, no touching, no talking, just silent spectating through shielded portals. But here's where things get ethically messy. Watching an alternate version of yourself breeze through life's roads not taken might sound harmless until you witness them suffering. Should tourists intervene if they see their doppelganger about to make a catastrophic mistake? The Prime Universe Directive, modeled after sci-fi's non-interference rules, would likely forbid contact to prevent timeline contamination. Yet human nature rebels against passive observation. One startup's leaked internal memo even suggested empathy adjustments, neural dampeners to suppress emotional responses during viewings. Critics argue this turns profound existential encounters into voyeuristic safaris. Then there's the economic elephant in the room. Who gets access, with costs projected to rival early space tourism? This could become a playground for the ultra-wealthy, literally paying to peek at lives they might have lived. Philosopher Nina DeWitt raises a chilling point. If we commodify alternate realities, do we reduce entire universes to entertainment? A grieving parent who can't afford to visit a timeline where their child survived isn't just excluded, they're taunted. Yet proponents counter that multiverse tourism could be humanity's ultimate therapy. Seeing the paths untaken might dissolve regret, proving that no single choice defines us. A pilot study using VR simulations of what-if scenarios found participants reported 30% less anxiety about past decisions. The real version could offer something even more profound, not escape but perspective. The question isn't just can we build this technology, it's whether we're ready for the emotional fallout of meeting the ghosts of our might-have-beens. Because once you've stared into the eyes of another you, There's no unseeing the infinite reflections staring back. In a world where fossil fuels never gained a stranglehold on civilization, what would Earth look like today? Picture timelines where Nikola Tesla's wireless energy dreams came true, where electric cars outpaced gasoline models by the 1920s, or where governments bet big on solar power right after the oil shocks of the 1970s. These aren't just fantasy scenarios, they're branches of reality that might exist somewhere in the multiverse's infinite tree, and the differences would be staggering. Take air quality. In our timeline, cities like Beijing and Los Angeles spent decades choking under smog, while in a green tech-dominated reality, skyscrapers might be draped in photosynthetic algae panels scrubbing the air as they generate power. Rivers there could run clear, spared from the mercury and microplastics we're still battling. Even the oceans might teem with life, their acidity levels never spiking from unchecked carbon emissions. The irony, many of these alternate Earths likely used technologies we already invented, just too late or without enough political will to scale them. But here's the wrenching question: if these cleaner timelines exist, could we somehow learn from them? Quantum theory suggests that information can't cross between universes, but human ingenuity has a way of bending the rules. Historians have studied adjacent possible innovations, ideas that hovered on the edge of feasibility in one era only to bloom in another. What if we treated parallel realities like a global brainstorming session? A world that cracked fusion in the 1980s or perfected carbon capture by 2000 might not be able to mail us blueprints, but their existence could reframe our own sense of urgency. The real lesson isn't about stealing tech from alternate selves. It's recognizing that our current climate crisis wasn't inevitable. At every fork in the road, there were paths not taken, policies abandoned, inventions shelved, warnings ignored. Those choices shaped this timeline, but they don't have to define its future. The multiverse's greatest gift might be the perspective it offers. Disaster isn't destiny. Somewhere out there, a version of Earth got it right. And if they could, why can't we? What if the greatest wars in history weren't fought across borders but across dimensions? Picture a shadow conflict raging beyond our perception, where entire universes battle not for land or ideology, but for the very fabric of existence itself. The terrifying truth is this: in a multiverse of infinite resources, one thing remains scarce: stability. And when one reality grows desperate, the walls between worlds might not hold. The sci-fi series Fringe painted this nightmare scenario with chilling precision. Its observers weren't just time travelers, they were refugees from a dying future dimension, invading ours not with bombs but by rewriting physics itself. Their weapon of choice, a device that could lower the gravitational constant in localized areas, turning human bodies into puddles of gore. Far-fetched. Perhaps, but the underlying science is eerily plausible. If brains can collide to birth universes, who's to say they can't be weaponized? Now consider the dark side of cosmic inflation. If bubble universes expand at different rates, a rapidly inflating reality could theoretically encroach on a neighboring one, not with armies but with the unstoppable force of space-time itself. The result, a war fought not with soldiers but with fundamental constants. Imagine a universe where electromagnetism is stronger, slowly overwriting ours, where the very atoms in your body suddenly can't bond. It's less an invasion and more an existential rewrite. Even more unsettling are the resource wars no one sees coming. Our universe's dark energy seems plentiful, but what if another reality's expansion depends on siphoning it from others? The cosmologist Andre Lind once speculated that advanced civilizations might learn to harvest vacuum energy. In a multiverse, that could mean tapping into parallel realities like cosmic straws, draining their potential until they collapse into nothingness. The most terrifying part, we'd never see it coming. A hostile dimension wouldn't need spaceships, just the ability to tweak quantum fields in ways that render our physics obsolete. One day, the speed of light might inexplicably slow. the next protons start decaying. By the time we realized we were under attack, it might already be too late. Yet amid these grim possibilities lies a strange comfort. If such wars were possible, wouldn't evidence of them already be etched into the cosmos? The fact that our universe's laws remain stable so far suggests either that dimensional warfare is impossible, or that something or someone is keeping the peace. That silence might be the most profound message of all. In an infinite multiverse, coexistence isn't just preferable, it's the only way anything survives. Scientists at MIT aren't just studying the multiverse, they're attempting to create it. Picture a high-tech lab where researchers manipulate ultra-cold quantum fluids, coaxing tiny, self-contained bubbles to form under precise conditions. These aren't ordinary bubbles, they're theoretical analogs for infant universes, complete with their own space-time rules. The process hinges on a phenomenon called false vacuum decay, where a high-energy state abruptly collapses, birthing a new pocket of reality. It's like striking a cosmic match in a darkened room, only here, the spark could ignite an entire cosmos. Now, before visions of mad scientists flickering light switches to spawn worlds dance in your head, there's a catch. These lab-grown universes would be microscopic, short-lived, and utterly sealed off from ours. Think of them as quantum fireflies, flashes of existence contained within the experiment's magnetic traps. The real breakthrough lies in what they reveal. If we can simulate the conditions that spawn universes, we might finally understand how our own came to be. It's cosmic archaeology done with lasers and superconductors instead of shovels and brushes. But with great power comes, well, you know the rest. If humanity ever graduates from simulating universes to actually birthing stable ones, the ethical questions would dwarf anything in science fiction. Does creating a universe make you its god, its parent, or just its accidental landlord? Philosophers like Nick Bostrom warn of creator responsibility, the moral duty to ensure a fledgling reality doesn't collapse into suffering or chaos. And what if that universe develops its own conscious beings? Suddenly, lab safety protocols aren't just about preventing explosions, they're about safeguarding entire civilizations we might never meet. Critics argue this is all speculative hubris, that playing universe maker risks consequences beyond our comprehension. Supporters counter that every leap in science, from splitting atoms to editing DNA, began as what-if heresy. The truth likely lies in the middle. MIT's experiments won't spit out a twin Earth anytime soon, but they're proving something profound. The laws that built reality might not be one-time miracles. They could be reproducible, even controllable recipes hidden in the quantum fine print, waiting for us to read them. Whether these experiments lead to practical creation or just deeper understanding, one thing's certain: the line between studying the cosmos and participating in its design is blurring. And that changes everything, not just about how universes begin, but about our place in the grand scheme of existence. After all, if a universe can be made in a lab, what does that say about the hands that might have shaped ours? Here's a fresh perspective to shake your sense of reality. What if the world you're experiencing right now isn't the main version, just one copy in an endless cosmic library? Imagine walking into a vast hall of mirrors, each reflection slightly different, with no way to tell which one started the chain. That's the unsettling question at the heart of the anthropic principle. Why does our universe seem so perfectly fine-tuned for life when statistically it shouldn't be? One camp argues we must be special. The fundamental constants, gravity's strength, the charge of an electron are calibrated with razor-sharp precision. Tweak them even slightly and stars wouldn't ignite, atoms would flee each other, and life as we know it couldn't exist. This Goldilocks perfection suggests deliberate design, as if our universe were handpicked from a menu of failed drafts. But here's the twist: multiverse theory flips this logic on its head. If infinite universes bubble into existence with random physical laws, of course we'd find ourselves in one where conditions allow our existence. You wouldn't ponder why you're breathing oxygen in a room filled with it. You're here precisely because it's the only room where you could be. Statistically, barren universes outnumber habitable ones vastly, but no one's around in those voids to complain. Yet the debate gets wilder. Some philosophers propose a third option. What if we're not the original universe but a descendant? Picture a cosmic version of generational photocopying, where each new universe inherits slightly tweaked physics from its parent. Over eons of branching, life-friendly parameters might emerge not by chance, but through a form of cosmological natural selection. In this scenario, black holes could act as reproductive organs, birthing new universes with mutated constants, some sterile, others fertile. So where does that leave us? Either we're astonishingly lucky, impossibly chosen, or just one audience member in a never-ending multiversal play. The truth might be humbler than any option. Perhaps prime is a meaningless concept in an existence where every reality is equally real. After all, in an infinite expanse, isn't every universe both central and peripheral at once? The mirror hall has no original, only reflections stretching forever. Science isn't about belief, it's about proof, and when it comes to parallel universes, researchers aren't just philosophizing. They're building experiments that could finally crack reality's deepest mystery. Picture a lab where scientists aren't studying particles or stars, but the very boundaries of existence itself. First up, the hunt for quantum gravity. Einstein's relativity explains the cosmos, quantum mechanics rules the tiny. But where they meet, physics breaks down. Now, sophisticated detectors like LIGO are listening for gravitational waves from the universe's birth. Why, the pattern of those primordial ripples could reveal if our cosmos collided with another in its infancy, like cosmic fingerprints on a window between worlds. Some models even predict telltale circular patterns in the cosmic microwave background, ghostly bruises from a long-ago brain collision. Meanwhile, deep under the Swiss-French border, CERN Large Hadron Collider isn't just smashing protons, it's probing for extra dimensions. By tracking how energy disappears during collisions, physicists could spot particles leaking into hidden dimensions like marbles rolling off a table into unseen space. The math suggests gravity might be weaker in our universe because it's spilling into neighboring brains, a theory that could explain why gravity is so feeble compared to other forces. But perhaps the most mind-bending evidence might come from staring into cosmic voids, those vast, empty regions between galaxy clusters. If another universe brushed against ours, its gravitational tug could create measurable distortions in these voids, like invisible hands pressing against spacetime's fabric. Telescopes like the Euclid satellite are mapping these voids in unprecedented detail, hunting for anomalies no single universe theory can explain. The beauty of these experiments. They don't rely on faith or philosophy, just cold, hard data. Whether through gravity waves, collider data, or cosmic cartography, science is closing in on answers. And if even one of these hunts succeeds, the implications would rewrite not just physics textbooks, but our very understanding of reality's architecture. After centuries of speculation, we might finally have receipts from the multiverse. Let's take a step back and marvel at the sheer audacity of it all, from Schrödinger's undead cat to bubble universes frothing into existence, from time-traveling Avengers to monks navigating dream realms as real as waking life. The evidence isn't just in equations scribbled on blackboards. It's in the eerie déjà vu you can't shake, the childhood memory your family swears never happened, even the uncanny survivor stories that defy statistics. Science, philosophy, and the echoes of ancient wisdom all whisper the same tantalizing possibility. Reality isn't a single stage, it's an endless performance with infinite versions of the same play unfolding simultaneously. Here's the thought that should linger long after this video ends. If every choice spawns a new universe, if every quantum possibility blooms into its own timeline, then somewhere, another you is living every road not taken. The shy teenager who asked out their crush, the artist who never abandoned their sketches, the scientist who cracked cold fusion but dig deeper and the question becomes unnerving. If all those versions are equally real, which one is the real you? The one watching this or the ones who clicked away, the one who thrives or the one who struggles? Or is you something more fluid, a thread weaving through countless realities, gathering fragments of experience no single timeline could hold? Now turn the lens on yourself. Ever had a moment so inexplicable it felt like a glitch in the matrix, a conversation you swear happened differently, an object that vanished and reappeared where you know you already checked? Maybe it wasn't forgetfulness, maybe it was the universe next door brushing against yours just long enough to leave a mark. So hit pause and ponder. In a multiverse where every possibility exists, does that make life more meaningless or more miraculous? Drop your wildest glitches in the comments, because if there's one thing we've learned, it's that reality is far stranger than we're taught, and the most thrilling part. This might just be the beginning of the conversation.